Saying hey from West Virginia again, and then again, maybe not. But let's get joke of the day because that's what we can count on. So, what did the hat say to the tie? Well, you hang around, I'll go on ahead. I'll go on ahead. Hang around. Okay. Well, anyways, let's take a look at solving multi-step equations, part 2. We've already taken a look at multi-step equations where we said, okay, we need to simplify the side and simplify this side, and then once we get them as simple as we possibly can, we need to get all the variables on one side, we need to get all the constants on the other side. And then what it did is it kicked it back into equations that we knew how to do. The beauty of what we had in there was that all those variables, when we separated them out and got all the variables on one side, we had a coefficient of just a 1, or maybe just a -1. We only had to go through and change all the signs. So what's going to happen here is we're not going to have coefficients of 1 anymore. That's going to stretch us a bit. But we need to recall those golden rules of algebra. The first one being that because this is a pan balance, what we do on one side, we have got to do on the other side to keep it all balanced out. And the second one being that we're going to undo what has been done to the variable in opposite order. In other words, we're going to reverse those order of operations. We've not seen this come into play yet. Now we're going to see it. So take a look at this example that we have here. Now remember, I said I like to pretend like this is a wall, and I like to draw my wall over there so that I can see what has been separated. And on this side, I have variable and constant. In other words, there's no like terms that I can combine up, because what I definitely want to do is I want to simplify this side as much as possible and simplify this side as much as possible. But each side is as simple as it will get, because I cannot put the 5z and the 16 together, and the 51 is just sitting there by itself. So now what happens is we're looking at it going, oh no, wait a minute. When I had just perhaps a z plus 16 equals 51, I knew what to do. Or perhaps when I had just a 5z equals 51, I knew what to do. I'm going to subtract 16 in this case. I'm going to divide by 5 in this case. But notice I got two operations I've got to take care of. I need to divide by 5 here to create a positive 1z because we want our coefficient to be a positive 1. I also need to subtract that 16. Now I'm going, oh no, which one do I do first? I'm not sure. Well, reverse those order of operations. So in other words, if I knew what the z was, because remember that's the whole goal. In the end, I'm just trying to figure out what is z going to be. When I subtract that 16, I'm going to find out that that z is going to be a 35. So my goal is trying to figure out what number can be plugged in for that z so that when I do order of operations, I create truth and the left and the right side are the same. What number will z be? But see, I don't know what that number is going to be. So I'm having to work backwards to figure out what that number is going to be. That's the whole goal. That's the whole thing. That's the whole gist of solving equations. You are working backwards to figure out what number can be plugged in for that variable. So in this case, I'm looking at it going, well, if I knew the z was a number like this, I'm going to pick an easy number. Let's call it a 10. If I knew the z was a 10, like I solved it here, like for instance, okay, let's take our 5z equals 50. Let's turn it into a 50 instead of 51. In that case, z is a 10. So once I know that z is 10, I'm going to plug it in. I'm going to follow correct order of operations. So I'm saying here, well, whatever I come up with for my z, I'm going to plug it in right here. I'm going to follow order of operations. I better get the same thing over here that I have over here, and over here I got a 51. So when I do order of operations, I better get a 51. So if I knew what z was, let's say it was a 10. Then when I check it, I'm going to multiply first, and then I'm going to add. Because PEMDAS, your order of operations, says that we're going to do this multiplication here before we do this addition. So if that z is a 10, I'm going to multiply, and then I'm going to subtract. Now, I'm reversing my order of operations. I'm going to undo what's been done to that variable in opposite order. The last thing that I said was adding 16. That is the first thing that you undo. So the opposite of adding 16 is to subtract 16, and I'm going to subtract 16 from both sides, leaving me with 5z equal to 35. Now in order to get that z by itself, okay, that's pretty easy because that looks like this. I know at this point I'm going to go through and I'm going to divide by 5, and that will tell me that my z is going to be a 7. And just like before, we can check it. We can always check these. We've been checking them so many other times. That doesn't change at all. So in order to check this, what I'm going to do then is I'm going to plug that 7 right here where that z is, and I'm going to say 5 times 7 plus 16. I better get a 51. Well, 5 times 7 is 35, because remember, I'm following correct order of operations. It says let's multiply and then let's add. And 35 plus 16, does that give me 51? Yep, it sure does. So since truth was created, I know that that's the right answer. Okay, so similar idea is going to happen here. Once again, I like to draw that wall. There's the fulcrum in the middle of the pan balance. And this is in this side of the pan, and this is in this pan. So now what I want to do is I want to get that in by itself. Now notice this is as simple as it can possibly get. I cannot put that 14 in together with that 8. It's not going to happen. And this is as simple as it's going to get. So I want to get everything away from that in. And once again, I'm going to reverse my order of operations. If I knew what the n was, let's pick an easy number, a 10. If I knew that n was a 10, I would multiply first and then I would subtract because order of operations says multiply and then subtract. But I don't know what n is. That's my goal down here. I want to figure out what it is. So I have to work backwards. I have to work backwards through this. So I'm going to undo what's been done to the variable in opposite order. The last thing we said was subtract 8. That's the first thing we're going to undo. And to undo subtracting 8, we're going to add 8. So that gives me 14n, and on this side I get a 42. Now, in order to get that in by itself, that's easy. I'm just going to go through and I'm going to divide by 14. 42 divided by 14 is a 3. There it is. And once again, I can check this just like I've checked all the others. I'm going to put that 3 right here where that n is. Sitting beside, 14 times 3, sitting beside means multiplication. And now I'm going to follow the correct order of operations, which says let's do that multiplication before we subtract. 14 times 3 is 42, and 42 minus 8, does it give me a 34? Yep, it sure does. And I created truth here. That means that n really is a 3. Okay, let's take a look at a few more examples. You know I like to give you lots of examples so you get really good at this. So once again, here's that wall. And notice on this side, it is as simple as it can possibly get. The x is being divided by a -5. That's kind of complicated, but it's not like I can put these two terms together. And this is only one term. So now, once again, I'm going to reverse that order of operations. If I knew what the x was, let's say it's a 10. I would put the 10 in there. According to proper order of operations, if I was to check that 10, what would I do? Absolutely, I would divide by that -5 first, and then I would add 3. Because like we said before, PEMDAS says, let's do that division before we do that addition. Now I'm going to reverse this because I don't know what that x is. That's what I'm trying to figure out. The last thing that we said was add 3. That's the first thing we're going to undo. And how do you undo adding 3? Oh yeah, subtract 3. So that will leave me with x over -5. And then on this side, a -3 minus 13, if you need to, call it adding a -3. And -3 plus a -13 plus a -3 will give me a -16. And now I need to undo this division that's right here. And the way that you undo division is that you multiply. So I'm going to multiply this side by that -5, do the same thing over here. And remember, when you multiply fractions, you're going to cancel on those diagonals. You're still in my math gang. Let's cancel on those diagonals. And then now on this side, we have a -16 times a -5. Negative times negative is positive, and 16 times 5 is 80. And just like every other time, we can check this. When we check it, what we're going to do is take that 80, we're going to put it right here where that x is. So we're going to take the 80, divide it by a -5, and add 3. We better get a -13 out of that. We're following proper order of operations now, which says do that division and then add. 80 divided by -15 is a -16. Sorry, 80 divided by a -5 is a negative 16, and negative 16 plus 3, do you get a negative 13 out of that? Yep, you sure do. So just like before, we created truth. That tells me, yes, my answer really is positive 80. Okay, one more, and then we're going to take a look at another idea here. Here is that wall, and notice this side is as simple as it can get. There's my variable with its coefficient that cannot be put together with that negative 4. This side is as simple as it's going to get, so I'm going to reverse those order of operations. Yet again, if I knew that that p was, say, for instance, of 10, what would I do to that 10 first? Absolutely, I would multiply, because that comes before this subtraction in order of operations. These two are sitting beside each other. That indicates multiplication. So correct order of operations, if I plugged a number in there, I'd multiply and then subtract. I'm reversing my order of operations, though. Put that thing in reverse. So when I reverse it, the last thing I said was subtract 4. That's the first thing I'm going to undo. And you undo subtracting 4 by adding 4. So I'll add 4 to both sides, giving me 7/8 p equal to 14. And you're familiar with this. We know how to work with fractional coefficients. We know that if we're going to divide by that 7/8, that is the same thing as multiplying by its reciprocal, 8/7. We're going to go for the jugular because it's cleaner, it's faster. So let's multiply by that 8/7 here and do the same thing over here. And there it is again, multiplying those fractions. You're still in my math gang. We're going to cancel on those diagonals. We're going to cancel up and down, and then we're going to shoot straight across. Notice here the 8's cancel, the 7's cancel. We're left with the p all by itself like we wanted. And then notice on this side that if we put that 14 over a 1, 7 goes into 7 once, 7 goes into 14 twice. Nothing happens on this diagonal with the 8 and the 1. Check up and down. Nothing's happening with a 2 and a 1. Nothing's happening with an 8 and a 1. We are ready to shoot straight across and multiply. 2 times 8 is 16. And in that denominator, 1 times 1 is 1. We don't have to show that in the denominator. So my p is going to be a 16. And yet again, we can check that. So all we have to do is take that 16, plug it right here. So 7/8 times the 16 minus the 4, we better get a 10 out of that. And there it is again, canceling on those diagonals because of multiplying those fractions. 8 goes into 8 once, 8 goes into 16 twice. And now we have 7 times 2 is 14. And 14 minus 4, does that give us a 10? Yep, sure does. So truth was created, therefore we know that's right. Okay, just a couple more examples. I want to take a look at a situation here where the variable is spread across the equal sign, because you'll notice in each of the previous 4 examples that variable was on one side of the equal sign. We have nothing over here but a number. But notice in this case, here's my wall, and I've got a variable on this side and I've got a variable on this side. Well, previously we had said when that variable is spread across the equal sign, all we have to do is get all the variables on one side, constants on the other side. And it doesn't matter which side the variable's on. You can get it on this side or you can get it on this side. It makes no difference. Just separate them. So in other words, in this pan of the pan balance, I've got 4 x's, and in this pan of the pan balance, I've got 7 x's. So I could either take all 4 x's out of here, and if I do, I better take them all out of here. Take 4 x's out of here. Or I can take the 7 x's out of this pan, but if I do, I have to take 7 x's out of this pan, and I don't have enough there. So my best bet, frankly, would be to go ahead and take these 4 x's out of here and take them out of here as well, because I have enough to make that happen. If I took the 7 x's out and tried to take them out of here, I'd go in the hole, which we know how to work with negatives. We're okay, but let's make life simple. So here, once again, sign in front's the sign that goes. You put that name tag on the front when you go to the meeting. You don't put it in the back. Put it on the front so that I can recognize your face with your name tag. This is a -9. Keep the sign with it. And now on this side, when I have 7 x's and I take 4 of them out, I'm left with 3 of them. Aha. Now we put all the variables on this side. That means all the constants need to go on the other side. So this 12, we got to get rid of it so that all the constants are in that pan right there. So that means that I'm going to subtract 12 to get it out of that pan, but I better subtract 12 over here as well. Leaving me with a 3x over here, and on this side a -9 minus 12, or if you prefer plus a -12, gives me a negative 21. Now, in order to get that x by itself, in other words, a coefficient of positive 1, I'm going to divide by 3 and divide by 3 here as well. And when I do, negative 21 divided by 3 is a negative 7. And 3 divided by 3 cancels, and I'm left with an x. There it is. And just like every other time, we can check to make sure this is right. Because we know that this is telling me if x is a negative 7, I should be able to put a negative 7 here and here as well. And when I do the order of operations over here and do the order of operations over here, I'll get the same number on both sides. So let's check and see if it works. Plugging that negative 7 in for the x. And we'll follow that order of operations, which says we better multiply here first. So I have a negative 28 minus 9. And then on this side, 7 times negative 7 is a negative 49. And 28 minus 9 is a negative 37. And over here, negative 49 plus 12 is yet again a negative 37. We created truth. We know that that's right. Okay. Let's try one more just because we want to feel very confident about this. And I think one more example will help us to feel confident. So let's see here. We've got example number 2 going, and we have a 6 minus y equal to a 5y plus 30. So here again, I like to draw my wall so that I see how things are separated. And notice this side is as simple as it'll get. I cannot take that negative y and put it with the 6. It doesn't happen. They're not like terms. Same thing over here. That 5y will not combine with the 30. They're not like terms either. I can't do it. So now I need to shift things across that wall. I need to separate my constants and my variables. So I can either deal with that negative y in this pan and add a y, or I can take this pan and subtract the 5y. It doesn't matter which way I go. Now just, we've played it safe so far. I want to prove a point that you really are smart. You really can do this. What if we go ahead and take that 5y out, which we've never done before because we've always been worried about going in the hole. But I want to prove to you, you know sign numbers. You've got this. You're fine. And I really want to stress to you, it really does not matter which side you put your variables on. Notice this one, my variable's on the right. It doesn't matter, just separate them. So when I take 5 y's that are in this pan and I take them all out, I don't have any of them left. They're gone. I'm only left with a 30. But in this side, notice I was at a negative y minus 5y. I'm not really adding anything to the pan, but I am combining up like terms. So this is a negative 1 minus 5, or look at it as plus a negative 5, however you need to look at that. So a negative 1 plus a negative 5 will be a negative 6y. So I have 6 minus 6y. Notice that threw all the variables on this side, which means all the constants have to go on this side. So that 6, got to get rid of it. So I'm going to undo it. Now remember, sign in front's the sign that goes. This is a positive 6. It's not a negative 6. That negative goes with this term right here. This is a positive 6. So how do I undo that? The opposite of positive 6, or the opposite of adding 6, would be subtracting 6, or a negative 6. We're always going to do the opposite when we're moving things across that wall. So here they cancel out. Be very careful again. Sign in front's a sign that goes. Keep that name tag on that front. This is a negative 6y. And on this side, 30 minus 6 is a 24. Now I'm ready to go through and divide by that negative 6, giving me y equals, and positive 24 divided by negative 6 is a negative 4. There it is. And I'm going to check it real fast because I want to make sure that I'm right. And that's the beauty of all these equations, guys. You can check every one of them, every single one of them. You just take out negative 4, you plug it right here, and you plug it right here. And then you follow that order of operations and make sure you get the same number on both sides, creating truth, and then you'll know it's right. So here, the opposite of negative 4, subtracting a negative, is really adding a positive, so that gives me a 10. And on this side, when I multiply, 5 times negative 4 is a negative 20. And negative 20 plus 30, does that give me 10? Yep, it sure does. I created truth. I know that's right. So hopefully this helps you with more of this multi-step equation idea. Being that, you still need to make sure that all your variables and constants are separated. That you've got all your variables on one side, constants on the other, or flipped around. It doesn't matter. Just get them separated. and make sure that you have this side completely simplified. This side completely simplified before you start moving things across the wall. And in order to get rid of it, you have to do the opposite. You have to undo it to get rid of it. And so that leads me back to the two golden rules of algebra. Once again, those golden rules say you have a pan balance. You have to do the same thing on both sides to keep it balanced. And you are going to reverse those order of operations. If you knew what that variable was, because that's the goal, what is the variable? What number represents it? If you knew what that number was, you'd plug it in there and you would follow correct order of operations. But since you don't know what it is, you're working backwards. You're putting it in reverse. And so take that thing, put it in reverse, and do the opposite in opposite order. And I hope that helps. Have a great day.